I explained one sample t-test, two sample t-tests, and I said in two sample t-tests we have paired and independent. I gave an example of independent, and I said I will tell you the difference between paired and independent sample t-test. Now let me start. When we talk about an experiment, we have observation units. I have response. The response is got from the observation units. Our response is got from observation units. Let me explain. So we are talking about lifespan of bulbs. What are the responses? The lifespan. Where did we get the lifespan from the bulbs, the electric bulbs? So the electric bulbs, they are our observation units. Then the lifespan that we recorded are our responses. We're talking about scores of students in an exam. The students are our observation units because we got our response from the students. Why their scores are our responses. We are talking about age of anything. What else again? The color of cars. The cars are our observation units. Then the color we recorded, our responses. So now I've tried to explain what we mean by observation unit responses. Now, if the observation units in the first sample, they are the same with the observation units in the second sample, then we're talking about a paired two sample t-test. But if the observation units in the first sample, they are different from the observation units in the second sample, in that case, we're talking about an independent two sample t-test. In that case, we're talking about what? An independent two sample t-test. What's the difference? Now, one is that the observation units are the same for both groups, while in the other one, the observation units are not the same for both groups. Now, take note of the first example we did. We are assuming that the bulbs, we got 25 bulbs from Alpha Bulbs Company, and we got another 25 bulbs from Beta Bulbs Company. If you look at it, we have a total of 50 bulbs, and the bulbs that we use to get the lifespan, they are totally different. That's why this is an independent two sample t-test. Now, let me give you an example of paired sample t-test. Paired sample t-test. Let's say before I started this class, I gave you guys the first assignment. Before we started this lesson, this program, I gave you guys the first assignment. And after giving you guys the first assignment, maybe those that had little or no knowledge of arrow programming, they will get 0 over 100, 1 over 100, 5 over 100, 2 over 100. Then after teaching you for 3 days or after our third class, I gave you guys the same assignment to work on. And you guys started getting 80 over 100, 90 over 100, 89 over 100, 95 over 100. Now take note, I gave the same questions to the same people. The people I gave the questions to the first time are the same people I gave the questions to the second time. Now I have two groups. What are the two groups? Before I taught them and after I taught them. Now we record the scores of people before I taught them, and I also record the scores after I taught them. Take note, the people that are in before, they are still the same people that are in what? After. Now in this case, we're talking about paired two sample t-test. Another example. If I am trying to check the efficacy of a drug, let's say I have a poultry farm and I want to make my beds to be very large. That's my plan. Let my beds be very large so that I can sell them and make more money. So I met a veterinary doctor, give me a drug, and you give it to them. And observe their weight. So what I did is I recorded their weight. Bed 1, so I numbered all the beds. Let's say I have 10 beds. I numbered all the beds. This bed 1, bed 2 to bed 10. I numbered all the beds and I recorded their weight. So this is before I gave them the drugs. I recorded their weight. Then after giving them the drugs, I waited for 3 days and I recorded their weight. Now take note, the weights, they are the responses because the weight we are getting from the beds. The beds, they are what? Observation units. Now, the responses from group 1, which is before I gave them the drugs, they are still the responses from group 1. We are getting from the beds. The responses from group 2, we are also getting from the same beds. So that's what paired sample t-test. I believe you've understood this. If you have more questions on this explanation, you can ask me or you check online. So now when they give you two groups to compare, now you have to ask yourself, the two groups, do they have the same observation unit? Are they paired two sample t-test or are they independent two sample t-test? So that you will know what to use. If they are independent sample t-test, you will use the method we used in our last class. If they are paired sample t-test, you will use the method I'm going to teach now. And now remember, for paired sample t-test, we have two methods, two ways we can test it using this when the data is in the wide format, or you convert it to the long format. When the data is in long format, we use this. Then remember, for independent sample t-test, you can test for whether to assume equal variances or not, homogeneity of variance, whether you can test for that, whether you assume equal variances or not using the event test before you continue. So we are going to talk about the paired sample t-test, which I've already explained. So now let's assume, okay, let me simulate data for that. So let me use weight before. So this is weight of beds before. Let me simulate from, say, my uniform distribution, arrow unit. Let me simulate 28 data. The minimum should be 14. The maximum should be 50. Then let me simulate the weight after from my uniform distribution also. Let me simulate 28 also. Let the weight, the minimum I should have be 25, and let the maximum be 100. Okay, so let me simulate data. Okay, let me look for, let me see if I can do a work that the hypothesis will not be rejected. So far, will be rejected in all hypotheses. So now I have my two groups. Take note, the same beds. We just want to, now what's the test now? The efficacy of a drug. So a veterinary doctor or a manufacturer produce a drug and is saying that this drug can increase the weight of death. That's a claim he's making. You have to verify the claim. So to verify this claim, you are the data analyst. The best method is the paired sample test. You record the weight before you administer the drugs to them. Then you also record the weight after you've administered the drugs to them and check the difference. Now, with this, now you can know if the weights are similar or not. If the weights are similar, that means the drug is not working. If they are different, that means the drug is working. Very important. So how do we test? So we still use our t.test. Take note, we still use our t.test. Let me see if it is there. Oh, okay, let's go. Take note, look at it here, paired. For paired now, we'll change it to true. So we use our t.test. We'll put the first group, which is weight before. Weight before. We'll put the second group, which is what? Weight after. Now you use paired, we'll say true. I can spell the true completely. I just write T. Now for this, now we'll just leave. Let me run. If I run, I'll see my results. So this is my result. This is my result. Take note, you still use the same interpretation I explained in the last class. The same interpretation to work with your T, to work with your p-value. Now, in this case, you tell them when in the area you state the method, the test statistic, you state that we are using paired two sample t-test, and you state the reason why we are using it. We are using the paired two sample t-test because the observation units in the first group, that is before administering the drug, are the same with the observation units in the second group after administering the drug. So that's the reason. Then you state your p calculated value, you state your p-value. The decision rule is always the same. P-value is less than level of significance. You state the null hypothesis now in this case would be the weight before is similar to the weight after. Then if you want to interpret it based on the drug, you can say if the weight before is similar to the weight after, it means what? The drug is not working. The drug is not significant. Then the alternative hypothesis would be the weight before is not equal to the weight after, or you can say the weight before is less than the weight after, or you can say the weight before is greater than the weight after. Now, depending on what you want, is it one tail test or two tail test, your choice, what are you testing? Now, if you're interpreting it based on the drug, you want your hypothesis to be based on the drug, it means if you're using not equal to, it means the drug has a significant effect on the weight. That means after giving them the drug, that's a significant effect. Now, if you are using not equal to, yes, it means the drug has a significant effect, but you may not know if it has a positive effect or a negative effect. You want it to increase their weight, but it's possible that at the end of the day, the drug will reduce their weight. Now, if you use not equal to for this, not equal to will just tell you that the drug has a significant effect. It will not tell you whether it is a positive change or a negative change. So maybe for this particular work, maybe the best is to use greater than or use less than. So when you use less than, that means you are specific. You are trying to test in the alternative hypothesis, is it that the weight after, is it greater than the weight before? You are being specific. You are not just leaving it as not equal to. You are being specific. Is it less than? So in this case will be, let's be specific. So we can change the alternative. Alternative would say, look at weight after came second, so we can put less if weight before. Look at it. Correct. So let's see what changed. The p-value is supposed to change. P-value is 0.056, so it has changed. So we are being specific now. I want us not to reject. So let me increase this to 20. I don't want us to reject. Oh, remember, I didn't set seed. So if I simulate data again, I'll be getting different results. So let me set seed. Remember, you can set seed to any number. So that I will get similar results. Oh, correct. No, it's still less than. Let me increase this. Correct. In this case, the p-value is greater than the level of significance. So we are not going to reject. We are not going to reject. So this is how to do a pair two sample t-test. This is how to do a pair two sample t-test. So far I've taught 3 methods. I've taught 1 sample t-test, 2 sample t-test for independent, 2 sample t-test for paired. So the next thing I'm going to teach is ANOVA. We are going well. We are making progress. I love how we are going. So let's go over to ANOVA. ANOVA. When do we use ANOVA? Now take note. We use t-test when we have 1 sample or 2 sample, 1 population or 2 population. That's when we use t-test. Now, when we have more than 2 population or more than 2 sample, what do we use? We can't use 2 t-tests again. We now move over to ANOVA. We now move over to what? ANOVA. So when you have more than 2 groups, you move to ANOVA. When you have more than 2 groups, you move to ANOVA. Now, in ANOVA, we have different types of ANOVA. We have one-way ANOVA. We have two-way ANOVA. We have different types of ANOVA. So you have to learn all these. I will just teach maybe 1 or 2 of them. We have nested ANOVA. We have two-way with replication, two-way with interaction, all this. We have Latin square. Now, I'm not teaching statistics. If you want to get the code for any of them, it's very simple, like I've explained. So if I want to get code for Latin square, what will I do? I will just come to this Latin square. They are not difficult. Yeah, it would just be 1 line because you know the basic things. Latin square in arrow. So you go to this, you open. I'm trying to make everything easy for you. Get the code. So now you can replicate, you understand this code. What are they doing here? They are specifying, this is the data, they are writing their data. I believe everybody by now should know what rep mean, what they are trying to do. They are replicating this one time, they're replicating this one time, replicating it one time. So we should know what they are trying to do. Now we know why they use C, because they are considering set of different objects. That's why they're using C. So in this case now they are working with a data frame. So they specified it and they brought all of them together and made it a data frame. So this is the data. In this case, they converted it to a matrix. They changed the class to matrix. So that's what happened here. In this place, what are they doing? I've explained this. They're specifying that they want to use 4 graphs on one sheet, 4 graphs. That's the MF row. I thought another method we can use the layout method to also design to specify how we want our graphs to appear. In this case, they are plotting. What are they plotting? Frequency. This is what they are plotting. I've taught you plot. This is what will be in there. This should be in y-axis. Then this will be in x. This will be in y-axis. Then this will be in their x-axis. So this is just like a linear model. They want a linear graph. A linear graph. So this is like a regression. I will teach you that this is a regression model. So they want a linear graph. Right? This is a regression model, yes. So let's continue. So look at it. I say the regression. Okay, no. This is just plots. This is the y-axis. This is regression model. They will use LM. So this is a regression model. This is a regression model. And this is the ANOVA. ANOVA. So to do the Latin square, the code is still ANOVA. But you must arrange your data this way. This is how to arrange your data. You must arrange your data in LM this. Very simple. Then use ANOVA this. Then you also teach you how to interpret. Now the code is very simple. So yes, explaining all the methods. I will just explain one. Anytime you want any code in arrow, because you have taught you the basics, you can get any code you want, any code. Just for you to learn the method that you are using and master it. So now we'll talk about one-way ANOVA maybe. We'll go over to the next thing. What I've explained earlier, one-way ANOVA won't have more than 2 groups. Now for one-way ANOVA, we have only one factor and replication, one factor and replication. In two-way ANOVA, we have 2 factors, 2 factors, 2 factors. Now it can be either one factor and blocking, or the blocking can also be seen as a factor. So that is like 2. But in one-way ANOVA, it's one factor replication. Two-way ANOVA, we can have 2 factors, we can have one factor and blocking. Blocking also can be seen as factor. So take note, one-way ANOVA, one factor. Now let me explain what I mean by factor. If we are talking about, so let's say we have 3 companies. We've been using, so we'll come back with our alpha bulbs. So we have alpha bulbs. So treat ANOVA. We have alpha bulbs, we have beta bulbs. So let me create another one, gamma bulbs. So we have 3 companies. So what alpha bulbs and beta bulbs are existing. Then I want to produce a new, maybe a Chinese man came into town and wants to start producing his own bulbs. And he said his bulb is called gamma bulbs. And he's trying to tell us that his bulb is performing better than the existing one. That's what he's trying to tell us, that his bulb, the lifespan of his bulb, they are better than the 2 existing fans. We cannot just accept his claim. We have to verify his claim, because we have 3 groups, 3 population. We use ANOVA. We have only one factor. What's the factor? Bulbs. Now this one factor has 3 levels. What are the levels? Alpha bulb, beta bulb, gamma bulb. Now remember I told you what you will use to know whether to use one-way ANOVA or 2-way ANOVA is what? The factor. In this case, we only have one factor, which is bulb. And we have replication. What's replication? Let me show what I mean by replication. The data was replicated 25 times. Let me run all the data. This is alpha bulb. This is alpha bulb. It was replicated how many times? 25 times. It was replicated 25 times. So because it was replicated 25 times, we have one factor, which is bulbs. The three of them are talking about bulbs, three levels. One, they are replicated 25 times. So because one factor, one way ANOVA. That will explain. Now, let me explain if I'm talking about blocking now or two-way ANOVA. Assuming I have now bulb and I'm talking about the different type. So let's say if they have fluorescent bulb, they have this yellow bulb that we normally use that we are using before energy saving bulb came out. So let's say they have different types of bulbs. They have bulbs for cars, bulbs for kitchen, bulbs for stores, so different types of bulbs. Now, in this case, we have two levels. What are the different? The first level is what? The companies, the different bulb company producing bulbs. Then the second level is what? The different category of bulbs they produce. So in that case, we use two-way ANOVA. Just know that for two-way ANOVA, we have to. So let me use the education system to explain it better. So let's say I want to test the CGPA of students in three different departments: math, stats, geology. Now, if I just pick students randomly, 20 students from mathematics, 20 from geology, 20 from mathematics, and compare the three of them, math, stats, geology, that's one way ANOVA. We have one factor, which is what the departments, the different departments, that's one factor. And we have three levels. We're considering three departments. Now, it's possible that I will compare a student from year one in mathematics, and I'll be using year one student CGPA to compare final year students in math statistics. And that is not proper. It will lead to wrong conclusion, wrong estimate of your result, and wrong because why? The variability within your analysis is so much. Why will you be comparing CGPA of year one student to a CGPA of a final year student? No, that the variability will be so high. Now I can decide to introduce what they call blocking in statistics. What's called blocking? I can decide to group it. I will create 5 groups. Where are the 5 groups? I will gather all the year one students from mathematics, gather all the year one from physics, from statistics, gather all the year one from geology, and I will compare all the year ones. Then I will go over to year 2, gather all the year 2 from the various departments and compare. No similarity for year 3 to final year. Now, in this case, I have 2 factors. I'm using blocking and what? The different departments. So in two-way ANOVA will be the right tool to use for such cases. Now, back to our one-way ANOVA. How do I, now for you to do one-way ANOVA, you have to convert your data to the wide format. You have to convert your data to the wide format. Remember, that's why when I was teaching wide format, I told you it is very, 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 very important. Because why? You need it in cases like this. Now, so let's work with, we have to convert it to, let me call it bulbs 3. I've explained how to convert to long and wide formats. That's why you have to watch the previous classes before you come to this. So first I have to convert it to a data frame, a data table. So let me remember, for you to convert to data table, you need to call up the library. So let me add the third gamma bulbs. So I've converted it to a data table. So now I can run this. So let me see what my bulb 3 is. So I've been able, I using the last gamma bulbs, I have beta bulbs and alpha bulbs. So now is in the long format. So after converting to long format, I can now do my analysis. What is the analysis? So let me call it any name. I can call it my results. I can call it results. Then the code is AOV. AOV. Okay, they have different codes. So they use AOV. Let's start with AOV. Then you put your data first, which is lifespan. Then it's our symbol. Then the different groups are company, Then you state your data. What's the name of your data you're using for this work? Data is Bob 3. Bob 3. I can now run my analysis. Then if you want to see your result, you can use summary, write more results. You can just run results. Awesome. Let me show you something. You can run results. You can just highlight results and run, or you write results in line 848, only result and run. So this is the result. So if you want to see detailed result, detailed report of your results, just use the function summary of your results, so that you get a detailed. Now take note, are you seeing a detailed explanation of your results? Detailed explanation of your results. So we use summary result to get a detailed explanation of the result. What we need here is only the p-value. Now, for ANOVA, we are not using T statistics, we are using F calculated value, So the two things we need here is F calculated value and p-value. But remember, I told you, for you to use the F value to make a decision, you need your F statistics table. But because we are not going to, Aaron knows that we will not be with our statistical table always. That's why they are giving us the p-value. So with p-value, you just compare it with the level of significance. You don't need table. It has done all the calculations. So in this case, what's the p-value? The p-value is 0. So you also do the same interpretation. You state your null hypothesis, alternative hypothesis. Now in the null hypothesis, you can say the lifespan for the three companies are not the same. The alternative, the lifespan, no, the null is that they are the same. The lifespan of the three companies are the same. For the alternative hypothesis is that they are not the same. Then you state the alpha level of significance. You state you are using ANOVA. Why you are using ANOVA? The reason why you are using ANOVA, because we have more than 2 groups, that we have 3 groups, and we are testing for significant difference. Then you make your decision. So in this case, we are rejecting the hypothesis. Why are we rejecting? Because the p-value is less than 0.05. Now, take note. ANOVA will just tell you either you will reject or not reject. Now, in this case, we are rejecting. So rejecting means the 3 groups are not the same, right? Now, the 3 groups are not the same. What are we supposed to do since the 3 groups are not the same? What are we supposed to do? Like, what I mean is, the 3 groups are not the same, but which of them? Is it that the 3 groups are totally different from each other, or 2 groups, maybe 2 companies are similar, then one is totally different? Can you explain further? ANOVA doesn't have that capacity to explain further. ANOVA will just tell you the 2 groups are not the same, the 3 groups are not the same. But can't you give me detailed interpretation? ANOVA doesn't have that possibility. Now we have another way we can do this. We'll use our post hoc test to do that, to know which of the groups are similar, or is it that the 3 of them are similar or not. So post hoc test. So we have different post hoc tests in Arrow. So let's look for the code together. So let's say post hoc test in Arrow. They call it a multiple comparison test. Another name for it is multiple comparison test. Now, when do we use it? We use it when we reject the null hypothesis. Whenever you reject the null hypothesis in ANOVA, you are supposed to do a post hoc test. Now, because ANOVA will just tell you the groups are not the same, or it will not give you a detailed interpretation of the groups, which of them are different, like the groups that are different from each other. Now, we have different post hoc tests. We have Duncan multiple range tests. We have the Turkey. We have Turkey. Are you seeing? We have donuts. We have Fishers. We have if you look at another name, is it Bonferroni? So we have different multiple comparison tests or post hoc tests. So I think the 2 major comparison tests they use in statistics, the Turkey and the features. So now let's get the code. We need a library. What's the library? Multcom. So let me check if I have it. Multcom. I have it. So correct. So let me call it up. So I'm showing you how to get things yourself. That's what I'm trying to show you. mod com. I've taught you all the basics, so you can get codes now yourself and edit it. Now, okay. Let me explain what we call dependencies. Now, for this com to work, it needs MVT norm, it needs survivor, it needs TH data. Now, if you don't have all these packages already installed in your system, it will not, this com will not work. Just like there are prerequisites. They are like prerequisites. So if you don't have all these packages, com will not work. So because I have all these packages, that's why modcom. So whenever I run modcom will run all the prerequisites, all the packages that are needed for it to work. So that's what just happened here. So let's go back to, now what's the code? The code is just GLHT, the ANOVA that you did. Then you write lane. Now take note, this may not just be the only way to do this test. Different people are written code on how to do the 2-key HSD test. Now this is a code written by someone, the person saved it in what modcom. You can also find another code. If you don't like the way this person is writing his code, maybe you are not a fan of how he wrote the code, you don't like it, how the result is appearing, you don't like it, you can look for another, you open another page. Let me look at another package now. This man used this. Are you seeing another package? Post awk. So I'm just showing because we are getting to the end of this class. So I'm just showing you how to get codes yourself. I'm showing you how to get codes yourself because I've taught you all the basics. So post awk. So this on that way, on that where they saved it as what post awk. Let me see the code for it. So different, so post awk, you state the model. So this is how this person prepared their results. Are you seeing it? Different people can write code. So you just go and make use of them. If you still don't like this, this is how the result will appear for this man. For this, if you're using the library post awk, this is how the result will appear. This is how the result will appear. If you don't like this code, you go again, select another one. You can select another one. So you keep on opening. I'm just showing you. Let me see the library, what they use here. So another name for it is pairwise test for mean differences. So look at the code, the library they use. The code we'll be using for is pairwise.test. Are you seeing it? Pairwise.test, pairwise.test. So I've shown you 3 codes now that do the same thing. Now, why do I have 3 codes? Different people. You can also write yours and call it the name. So in this case, they are using Bonferroni. Yeah, they didn't use none. They use none. They can use Bonferroni. Yeah, they use HOLM. Like I said, we have different methods. Yeah, they use BH. Just use one and stick to it. Look at the two-key test. If you want to do it, this is the code you use, 2-key HLSSD. Let's look for the package. So look at what they use, 2-key HSD. Correct. So anyone you want. So let's just pick one and use. So let's see if we can use one. And they all have different way of interpreting it. So you select the one that is best for you. So let's use this. Let's just use this. So you choose the one that you want. So look at how I would replicate it. Let me look at how I will do this. So look at the code. I'm just showing you. So look at the code. I've called my library. So I want to use the code. So you write, I'm doing my 2-key test. 2-key HSD test. Let me just write 2-key test. So I can call it any name. I can call it post. I can call it post, maybe post awk. That's the name. Then the function here is GLHT. Then you state your ANOVA. What's the ANOVA model? The ANOVA model I created, I saved it as a result, comma. You state the function lin, this, you put MCP, which is the function. All these GLHT, LINFSCT, MCP, they are from the library multcomp, MULTCOMP. So just follow them, especially so you learn how to write code yourself. Okay. Now we can also learn about this. We can use our question mark and learn about the GLHT. So I've been able to copy the code. Then the next thing I will do summary. So look at it. After writing, are you seeing it? Are you seeing it? You can also check an example they did of the GLHT. Look at it. Are you seeing it? GLHT. Look at another example. Are you seeing it? So I think this spreadsheet may not be from the code. This spreadsheet may be okay. This spreadsheet is the group. So in our case, the group is company. So I will change spreadsheet to company. Uppercase C. So I'm showing you how to get codes yourself. How to get codes yourself after teaching you the what's happening. So company. Okay. So I can run now. Wait, let me see. Armor, there is the ANOVA table, correct? LINFCT, correct? Equal to MCP, correct? Pension is the group. This is my company. Equal to CUKEY. Okay, they are not contained as factor. Let me see. So company is not contained as factor. So I have to go back to here and go to, let me see the class str of my data bobs 3. So look at this, companies in character. So you're telling me that it's not in fact, it's not a factor. So I have to change it to a factor before it can work. That's the, I read the error message. I seen the error message. So I'm just trying to summarize everything. So you learn everything, how to do it yourself. I read it, so you've seen it as a character. So I have to confirm if what is a character. So it's a character. So I cannot use it for the analysis. I have to change it to a factor. Now the challenge is how can I change it to a factor? Let's try. So Bob's 3. Company. Wait, let me. Class. Let's see if this will work. Bob 3. Okay. So like I said, we have to change it to factor. So how do we change it to factor? So we want to change Bob 3 for company. So we change it to factor. I want to coerce it to a factor. Is a character now. So we can coerce it to a factor. What are we coercing? We are coercing Bob 3 character company. So let's see if it will work. So let me try my structure again. XTR structure of box 3 to know if it has been converted. Box 3 if it has been converted to factor is still a character. Correct. So company now is a factor. Remember, company before was a character. This is what we got before. Company was a character, but we've changed it to what? To a factor. So we can repeat this analysis and see. Let's see what we chose. Company of, okay, no, we have to run this analysis here. Correct. Now, remember, see, do you know why this gave me an error message? I'm using results. And because after passing it, I have to rerun every other thing. I didn't do that. I run line 851. So I have to rerun everything before this will work. So it has worked. So I believe we are learning. Always read your, so let me get you summary to get a detailed explanation of what I did there to talk. So this is it now. Look at what happened there. They compared beta bulb and alpha bulbs. What's the p-value? It's less than 0.05. It means there is beta bulb and alpha bulbs, they are not similar. They also compared gamma bulbs and alpha bulbs. There's a significant difference. It means they are not similar. They compare gamma bulbs and beta bulbs. There's a significant difference. It means they are not similar. Looking at this, what's the meaning? That it means the three bulbs, all of them are totally different from each other. None of them are similar. No two bulbs, no two companies are similar. So that's the interpretation. Let me see. So I've shown you how to get codes yourself. This is what we use. Let's see. Okay, we can also plot it. So let's see if we can plot it. Plot post hoc. Correct. Are you seeing it? Now I'm just showing you how to get codes. Now let me do it in a way that two of the groups will be similar. Let me do it in a way that two of the groups will be similar. 51. Let me do it in a way that two of the groups will be similar. No, they're still not similar. Okay, I have to set seed. Let me set seed to 40 so I can be getting similar results. Let me also change this to 50 and 180. Let me set seed. Okay, now the three of them are now the same. Correct. So now, in this case, now we rejected the null hypothesis. We also rejected null, and whenever I reject the null hypothesis for the normal ANOVA test, you now do post hoc test to compare each two. It will pick two groups and compare. So that's how it will do till it has compared two group, each of the groups with each other, like each group with other. It will compare each group with other groups. So looking at these beta bulbs and alpha bulbs, they are different. There's significant difference. Gamma bulbs and alpha bulbs, there's significant difference. But there's no significant difference between gamma bulbs and beta bulbs. So now, in as much as we rejected the hypothesis to say that there is a significant difference in the three bulbs, ANOVA will not give you detailed interpretation of which of them. Is it that the three of them are totally different from each other? Or is it that in the three, comparing the three can tell you that, yeah, there's significant difference, but maybe two of them are still behaving alike. So that's what we did here. So looking at these gamma bulbs and beta bulbs are behaving alike. That's why the p-value is greater than 0.05. So the two companies that are different is, if you watch it, if gamma and beta, they are the same, it means the one that is totally different is alpha bulb. So that's why if you compare alpha and beta is different, if you also compare alpha and gamma is different. So that means gamma and beta, these two companies behave alike, while alpha is behaving totally different from them. Now this is what we call post hoc test. when do you do post hoc tests? We have different post hoc tests. We have the 2K, we have the LSD feature, Duncan multiple range test. Just select one. There are different methods. Just select one and use. They all do the same thing. We only use post hoc test when the null hypothesis is rejected for an ANOVA analysis. So we are going to this one with ANOVA. We are going to stop here for today. We'll continue next week. And maybe we'll look for a way to round up the classes. I've shown you how to get code yourself. You can get any code. Thank you.